Hi, and welcome back to Risk Management. Today, the title of our talk is Illusions Part 2. We're continuing in our presentation of illusions. The reason we're doing so is to distinguish them from phenomena, or relata, two essential components of understanding causation, which in turn is essential for understanding most forms of risk. What we'll be doing today is going through and showing a couple of other types of illusions besides the visual ones we saw in the last class, like auditory illusions, or even integrated illusions which require multiple senses in order to create. We'll then also look at a couple of examples of modern science using understanding of the brain to create illusions that we never thought possible until recently, such as prosthetic limbs that respond to mental stimuli or mental inputs. Let's get started. To refresh our minds why we're having this discussion about illusions, remember our topic is risk. The definition is the probability that a stimulus causes a harmful effect. That means we need to know whether a stimulus really exists and whether an effect exists. Remember, we gave a definition of causation earlier, and causation is integral to our definition of risk. A change in a stimulus that determines a directional change in an effect. Again, we're going to talk about determination and direction momentarily in a future lecture. But right now, our lectures are preserving the concepts of stimulus and effect, how we know that phenomena, or otherwise said, relata, exist. I want to now give you a couple of examples of auditory illusions, ones that use our ears where we can be tricked into actually believing something. Shepard's tones, invented by Dr. Shepard in 1964, give us an example of infinitely ascending or descending pitch. Using a feedback loop, he changed the pitch, but he also changed the volume of the notes. As the pitch ascended or descended, the volume of the next note in the sequence was held the same by Dr. Shepard. After the pitch doubled or halved, depending on which direction he was going, the loop starts over in his recording. But he matched the volume to cover this cycling process. And in so doing, he gives a false, illusory perspective that the pitch is going on forever and ever up or down. Take a listen, see what you think. Okay, now that we've seen that very impressive example with Dr. Shepard's circumstances of infinitely ascending or descending pitch, let's now look at another example, the McGurk effect. The McGurk effect is very interesting because it doesn't just rely on one of our senses to trick us, it relies on the integration of multiple senses to trick us, namely our sight and our hearing. What I'd like you to do in the following sequence of 4 successive replayings of this videotape involving this man on the screen before you now is the first 2 times it's played, I'd like you to listen and watch this video. Next, after you've done that twice, I'd like you to close your eyes and listen to the same video again. See if you hear a different sound from watching and listening than when you only listen. Finally, if you really want to try to get involved with this, you could replay the video again, plug your ears with earplugs, and just watch and see if you think he's saying something by reading his lips different than what you actually are hearing. Okay, let's give it a try.
Ba ba, ba ba, ba ba. ba ba, ba ba, ba ba. Ba ba, ba ba, ba ba. Ba ba, ba ba, ba ba.
Wow, that's pretty impressive, isn't it? It's neat to see something like that happen, and it also shows us that seeing can be believing, or hearing can be believing, but maybe when you integrate it, it's not believing. The McGurk effect plays on a couple of integrated parts of our brain that take into account both sight and hearing and creates an illusion for us. I'd like to now relate the story of Michael May. This is a very interesting tale that was told in 2003 about a man who lost his sight when he was 3.5 years old in a chemical accident. His eyes were damaged irreparably, and so he became blind. When he became older, Michael May, in his 40s or 50s, was given prosthetic eyes, new eyes that were transplants in order to see. The problem was he didn't see exactly as was expected when he got his new eyes. That's because his brain had not wired up correctly in order to see. Well, what did Michael May see when he finally had his sight restored? Well, he saw motion, color, and shading or perception of that sort all normally. No problems there. But his facial recognition abilities, his depth perception, and 3D complexity understandings were basically non-existent. Now that's very interesting because he was 3.5 when he lost his sight. It suggests that the way we learn to see the world changes as a youth over time. Infants see differently than 7-year-olds. And so what did exactly Michael May not be able to see when he first got his sight back? Well, he had really big trouble recognizing people's facial emotions. Here are some examples of people with different facial emotions on your right. Michael May could not recognize emotive facial expressions. Nor could he recognize faces in sort of objects like the one here on the left, which is the man on the moon or man on Mars, where it looks like a rock formation in the shape of a human face. He saw nothing other than shadow and light, not even a depth perspective recognition that this might be a mountain range, let alone a face. What also was interesting was Michael May had the ability to have depth perception impaired. When he saw this Necker cube, a drawing of a simple cube, he just saw a bunch of lines, whereas most of us, of course, see a cube with 3 dimensions. However, Michael May actually had advantages over most people in some areas. Here's something called a Shepherd's table. In 1 and 2, the dimensions of the table are actually the same on the tabletop. I know it doesn't look like it to you. It looks like one's a narrow, long rectangle, the other's more of a rhombus, short, squatty rectangle shape. But if you look at the bottom, you can rotate the table, as it's doing in those 4 progressive slides, and you'll see the table rotate from one length to the other with no change in dimension. Michael May was exceptionally good at recognizing that these 2 tables were the same, whereas only about 63% of control subjects recognized that. So in some ways, Michael May had advantages over normal people with normal sight in being able to recognize certain perspectives. Michael May also was able to not have depth perception and so had no trouble recognizing that these 2 black lines on these railroad tracks were the same size, whereas most of us obviously would recognize a difference in length. Same goes for this illusion that I showed us earlier in part 1 of this series. Most of us recognize these 3 blocks as having different dimensions. Michael May recognized them as all the same. He wasn't tripped up by the fact that there's lines that suggest a 3-dimensionality to this portrait. He only looked at the objects and said, those are the same lines in each of them. Here's where it gets really interesting, and this is a wonderful experiment, I think, done in 2004. There's a condition of the brain called somatoparaphrenia. It's a fancy term to say there's a damage in the regions of the brain where sight and touch are integrated. You'll see here in this picture a subject on the left who's a normal subject. We're looking down from above at their brain, and on the right a subject where there's 2 red dots in the brain suggesting lesions or injuries in parts of the brain where somatoparaphrenia occur. That is, where the sight and the touch of a person are coming together in the brain to create sensations of perceptions of phenomena. So what they did in this study was they put the subject's hands under a cloth and they rubbed a wand against people's hands. Simultaneously, they put a rubber hand on the table in front of people and tickled the hand with a rubber wand in both the control subjects and those people with somatoparaphrenia. And what happened was very interesting. Normal subjects, when they had their hands being rubbed under the cloth, actually felt that their hands were being touched. The rubber hand was their hand and was being touched. In other words, people mistake where their actual hand is, and there's a rubber hand illusion where it feels like the rubber hand is your own hand being touched. So we can trick normal people with this illusion. What's interesting is in people with somatoparaphrenia, not only were they not tricked by that illusion, but they denied they had left hands. It felt like nothing was occurring at all, and they just saw a rubber hand being rubbed without the sensation of feeling. This is very interesting. What's the truth in this? And this leads us to the following, and I want to close this session today with this issue, which is in the future, as we start to understand more and more about how the brain integrates sensory inputs, there's the ability to manipulate that brain to have false inputs, or artificial inputs is maybe a better word, such as prosthetic limbs made out of robotics. And starting back in 2000, 2003 or so, there were implants made into monkeys' brains where monkeys could control robotic arms. We're talking Luke Skywalker type of technology here, where prosthetic limbs, simply from a few anodes in the brain, as well as some hookups to the nerves endings in somebody's limb, can create automatic prosthetic limbs. You can also do this where it's even controlled over the internet and the limb is in some different county, state, or nation. And you can control a limb using only your thoughts over the internet. Astounding stuff. The stuff of illusion, but illusion that's been helpfully controlled in order to help people overcome deficiencies and harms that they've suffered in life. Let's watch the next video to see a recent example of how limbs are being used in order to, illusions are being used and suppressed in some ways in order to help people.
Johnny Matheny has become something of a guinea pig for experimental prosthetics.
Hand open.
What he's testing here being the Johns Hopkins Applied Physics Laboratory, is a glimpse into the future of how humans and machines interact. It's a mind-controlled arm that attaches directly to his skeleton. And it's the result of a decade of work and $120 million of military funding.
So this is the first time that we're attaching a prosthetic device to an implant that protrudes out of his skin and allows the prosthesis to actually be physically attached to his skeleton.
Okay, elbow extend, elbow in. I had a problem with all the arms that I was working with. I was having skin breakdown on my stump. With osseointegration, you don't have to worry about the suction on the stump. You connect directly to the implant, and so therefore, you can continue wearing it, no matter what.
Johnny's implant allows for more strength and mobility, but maybe more impressive is he can control the arm with his thoughts. For this, he had to undergo another surgery to rearrange the nerves from his missing arm.
All right, so we'll just start with no movement. Ready? Let's pronate. Supinate. Go.
We are actually witnessing something that has never been done before, is Johnny really controlling that limb simply by thinking about it with normal intuitive thought. We are using wireless myobands to transmit that muscle activity. So now when he thinks of moving his missing limb, it now contracts those newly reinnervated muscles.
Elbow flexion, ready, and go. Hand open, and go. Wrist rotate in, and go. Ready, and go, and go, and go.
It's hard. Yeah, I've done hundreds of thousands of hours of mental exercises, just trying to do the different grips, bends, rotations, points, pinch. So anyone that, right after the surgery, they think they can step right back into it and, just start working it. I mean, you're in for a rude awakening. It takes a lot of time.
You wanna hand that to me?
Getting Johnny to communicate with the arm is only half the challenge. The ultimate goal is for the arm to talk back to Johnny. Soon, he'll be able to feel how hard or soft something is, to understand its texture and even its temperature. As he moves forward, Johnny represents a future where robotics goes from being a tool we use to actually becoming a part of us.
I want the ultimate arm. I want to be as near natural as a human arm as possible. You trust me?
Yes.
Handshake me. How you doing?
Good.
Good to meet you. I'm like the Model T of cars, or I'm the Wright brothers of airplanes. I'm the beginning. And as we progress, then you're going to see us finally move up to the Maseratis or these supersonic jets. So we're going to say, Back to the Future has begun.
Illusions don't just take the form of sensory inputs. Illusions also can take the form of things like accounting. And this will become important when we get to the financial portion of this class. Here's an example, Alcoa. On April 11th of 2016, Alcoa reported an adjusted earnings per share, that is the typical expectation of Wall Street investors to how healthy a corporation's investment portfolio and package is. They reported earnings per share of 7 cents, or $108 million in adjusted net income. They beat the consensus of investors of 2 cents very handily. Never mind the fact that it had missed consensus revenues of $5.2 billion by a whopping $250 million, a drop of 15% from a year prior. So how is it possible that a company that has lost over $250 million, dropping 15% in revenues from the year before, can still report a very healthy earnings per share? Well, to understand this illusion, we have to simply understand what earnings per share mean. Here's the equation for it right here at the bottom of your page. It's revenues minus costs over the shares of stock outstanding. Well, if revenues are flat or down, there's only 2 ways to get your earnings per share up mathematically. You can either drop costs of your company, or you can decrease the number of shares of stock that are in the marketplace. Either of those ways would increase the earnings per share if revenues are decreasing. So, one way to do this would be to fire people, or to outsource, or to automate processes. That would drop your costs. And maybe Alcoa has done some of that. But another way of doing this, the accounting magic kind of way of creating an illusion of corporate health when in fact the company is not doing as well as it might otherwise be reporting, would be to buy back the number of shares of stock out in the marketplace. By doing that, or by writing off equipment, for example, which could increase the amount of revenue that the company supposedly is taking in, you can create the illusion as an accountant that the company is healthier than it actually is. And indeed, it appears that's what Alcoa has done recently. In the last calendar year, since 2015 until April of 16, if you look at the left column, the GAAP, the generally accepted accounting principles or standard accounting net income of the company, took a drubbing, losing $501 million. But the company reported $532 million in earnings per share increases. How did they do this? Well, they gave accounting numbers that took into account what they called restructuring charges. Basically, by reorganizing the association, they were able to report net income by writing off depreciation that they otherwise really didn't have. Simply moving people around to different departments and reorganizing the company. Nothing new was produced, nothing more sold, but the company ended up being able to report a healthy income. Voila, magic on the balance sheet, an illusion that creates a different perspective on reality. So today we've talked about a number of other illusions, and I hope this has been helpful to you. I'll be interested to see what your thoughts about illusions are, And keep in mind, we need to be thinking about how to control for these illusions, or at least understand them better and anticipate them, so that we're not tricked when we're trying to decide whether something is a risk or not. I'll see you on the chat boards. Have a good day.